Dear students, welcome to the course of VLSI Circuits and Systems. Today's topic inverter delays. In our previous topic, we have completed the resistance, sheet resistance of layers and area capacitance of layers, and we have also done its continuity part, that is a delay unit, in our previous three lectures. So in the present lecture, we will continue these topics with one more interlinked topic, that is inverter delays. After completion of this lecture, you will be able to compute the expression for inverter delay based on sheet resistance and area capacitance of layers. Going into the details, just a quick review of what we have done in our previous class, that is the delay unit, otherwise called as time constant, represented as T, is R into C, the product of R into C. This example we have taken in the previous class as if a standard unit of capacitance is being charged through a sheet resistance consisting of an NMOS transistor. So what would be the time constant or delay unit is calculated as sheet resistance multiplied by standard unit of capacitance. So based on the technology, the values changes. If that is a 5 micrometer technology, the value of sheet resistance is 10 power 4 ohms and standard unit of capacitance is 0.01 picofarad. The product of these two will result in a time constant or delay unit as 0.1 nanoseconds. Same for 2 micrometer technology, where the sheet resistance value turns to be 2 into 10 power 4 and standard unit of capacitance turns to be 0.0032. In turn, the delay unit turns to 0.0064. Whereas for 1.2 micrometer technology, the sheet resistance value is same, 2 into 10 power 4, whereas standard unit of capacitance changed to 0.0023. In turn, the delay unit changes to 0.046 nanoseconds. So keeping these delay units for various technologies into consideration, in our earlier classes, while we are deriving the voltage versus VDS versus current ID relation for a MOSFET, we have started with electron transit time tau SD, which is given by the expression L square by mu n into VDS. This is known to us. So when we substitute the typical values of L, mu and VDS as L as 5 micrometer and mu n as 650 centimeter square per volt second, and VDS typically will be 3 volts for my 5 micrometer technology. And if we evaluate the value of transit time, that is equal to 0.13 nanosecond, which is very close to 0.1 nanosecond, which we have evaluated practically. So this is very close to the theoretical time constant calculated above. Coming to the inverter delays, we have two types of inverter delays to discuss. One is NMOS based and one is CMOS based. So always NMOS inverter will be of 4:1 ratio. 4:1 ratio here refers to ZPU by ZPD ratio. So in order to achieve a ZPU by ZPD ratio of 4:1, pull-up resistance should be 4 times the pull-down resistance. So the delay associated with the inverter depends on whether it is being turned on or off. So if it is an on inverter, for example, so consider a pair of cascaded inverters shown here in the figure. So how to calculate the delay? Then the delay over the pair, how to calculate this one? So when we take this transition, when the input to this inverter is going from 0 to logic 1, so definitely what happens, this NMOS inverter will have a pull-up network and a pull-down. So pull-down will be an NMOS enhancement and pull-up will be NMOS depletion, which is always on. So when you apply 0 to 1, what happens? Pull-down network will be on and the capacitance, the standard unit of capacitance which is connected here, will have a discharge path to the pull down transistor. So we need to consider standard unit of capacitance as this one, and pull down transistors sheet resistance Rs. So keeping Rs into delta Cg as tau, single tau. Now this is going to produce an output of logic low, from high to low. So which is going to be applied as an input here. So in this case, pull up device will be on, and whereas pull down device will be off. This is off. So in this case, this load capacitor, considered as standard unit of capacitance, will have a charging path like this. So here the R and C, heat resistance one, as is a pull up device. So this will be 4 times, this resistance value will be 4 times the pull down device. So in this case, R 4 times R into C will be the delay unit, that is represented as 4 tau. Here that is represented as tau. So in total, the inverter delay here driven through one NMOS inverter driven to another NMOS inverter is 5 tau. So that is written here, tau plus 4 tau is equal to 5 tau. So in general, we write inverter delay as 1 plus ZU by ZPD into tau in this type of circuits. Hope this is clear. So when we need to calculate the inverter delay of CMOS, let us consider this is a CMOS based inverter and this is a CMOS based inverter. So in general, our CMOS based inverter circuit diagram will be like this. Pull up will be PMOS, pull down will be NMOS, both the gates are connected, and this is your output and this is the supply and this is the ground. So here is the input and here is the output. As the input is connected to both the gates, that is what here the standard unit of capacitance is marked as 2 times Cg. So here also 2 times Cg, that is the representation. And whenever you are trying to make this transition, that is logic low to logic high, what happens? Definitely pull down transistor will be on and pull up will be off. So in this case, this 2 into Cg will have a discharging path through the pull down resistor. So the pull down resistor actually will have a sheet resistance or channel resistance value of 10 power 4. So which is treated as 10 power 4 into standard unit of capacitance is treated as tau actually, but because of this 2, we represents 2 times tau. So this is 2 times tau. Similarly, on the other end, whatever again the CMOS based circuit what we have, pull up with the PMOS and pull down with NMOS, this is the input and this is the output, supply and the ground. As this transistor, this inverter is giving an output of low from high to low, so a low input is applied here, so we'll make pull down transistor as off and pull up transistor as on. So here the capacitor connected will charge through this pull up network. So these 2 times standard unit of capacitance will charge through. So in a CMOS based circuit, the pull up will be 25 kilo ohm, that is 2.5 into 10 power 4 if you take. So 10 power 4 multiplied by Cg is tau, whereas 2 into 2.5 is 5, so representing 5 tau. So in turn, the overall inverter delay of CMOS based circuit is 7 tau. Hope this is understandable. Based on this topic, there are few lecture level problems. We can discuss this in our classroom. That's all for this topic. Thank you.